Okay, this is Simplifying Expressions with Properties, Student Handout 4. So you should be turned to Student Handout 4 out of your binder. This section you might have to pause a lot to fill in the blanks. We've already really done things using properties. Properties are just like the rules of math. You've been using the rules and just haven't realized they were a rule. So we're going over the rules and we're going to see where they have been applied to what we've been doing. So the first thing you should see at the top of your page is the chart of the properties. We've kind of talked about some of these already and I've taught you tricks. So I'm going to go back over those. First property we have is associative property of addition. The definition of associative property of addition is when adding terms, the grouping will not impact the solution. Grouping means parentheses or brackets or face brackets. Any kind of grouping symbols, those will not affect it as long as straight addition is being used. So an example you can write down is 3 plus 4 plus 1 is the same thing as 3 plus 4 plus 1. These parentheses don't matter because straight addition has been used. The way I use and remember associative property is the word associative. These two S's are kind of squiggly, like parentheses can be squiggly. So they remind me of two parentheses. So draw those two parentheses above your S's. And that reminds me of grouping symbols. So associative property refers to grouping symbols. So associative property of addition refers to grouping symbols with straight addition. You don't have to write this bottom part, but it just shows that if I do the straight addition, I'm going to get the same answer no matter where the parentheses were. That's what associative property means. Parentheses don't matter if I have straight addition. Then you have associative property of multiplication. Associative, okay, I see the two S's. It's going to be talking grouping symbols again. This time it's talking with multiplication. So when multiplying terms, the groupings will not impact the solution. So your parentheses, your brackets, your face brackets, whatever may be used, if it's straight multiplication, it won't affect the solution. So associative property of multiplication, an example could be this problem here where there's straight multiplication. They just changed up the parentheses. They're saying it doesn't matter what's grouped together, as long as it's straight multiplication, you're going to end up with the same answer. Again, you don't have to write the bottom half, it's just showing that you're going to get the same answer no matter what. So the S's remind me of parentheses. That's how I remembered it when I took a test on properties. That helps you, or you have some other trick, go for it. Next up is commutative property of addition. Commutative property is when you're adding terms, the order in which they are added can be changed. If everything is straight addition, it doesn't matter what order you add them in. You can add them in any old order. So an example of that, here's the two sides of my equal sign. I have 3x, a 5x, and a 6x. Well, that's going to give me the same thing as a 3x, a 6x, and a 5x. Even though they're shuffled, they're going to equal the same thing. both of them would combine to 3 plus 5 is 8. 8 plus 6 gives me a 14x. Both of them's going to get 14x on both sides of this, no matter what you do. So that's commutative property of addition. If I have straight addition, I can switch the order around and it doesn't matter. The way I remember that is the two m's in commutative. I can have switch the order, kind of looks like two arrows with those m things. I can switch the m's around and it still spells the word commutative. So order does not matter with commutative property of addition. I can flip any terms around as long as it's straight addition. Then we have commutative property of multiplication. When multiplying terms, the order in which they are multiplied can change. So same thing as addition, now multiplication. If I have straight multiplication, I can shuffle up the numbers, still multiply them together, and get the same answer. So here is an example. 3 times 5 times 4 is going to give me the same answer as 5 times 3 times 4. They're the same numbers, just shuffled. They're both going to give me an answer of 60. Again, how I remember that, my two m's can be flip-flopped, and it's still going to spell the word commutative. Okay, our next property is distributive. We've already gone over distributed. It's expanding an expression through distributing. Distributive property always has that parentheses, and you have the distributor. So here I like to do my little rainbow effect. This 3 would be multiplied by everybody. Distributive, it was pretty easy for me to remember because you're distributing out a number. And here would be the simplified expression. Okay, moving on to the next part. Okay, reviewing what combining like terms means. When you're simplifying expressions by adding and subtracting like terms. It means they have the same last name, same variables, or they're both constants. For our example, I have 4x minus 2x plus 3y minus 6y plus 7 plus 3. So I notice I'm going to square all my x's. I'm going to circle my y's. I'm going to squiggle my constants. And combining like terms, I'd combine squares with squares, circles with circles, constants with constants. And when you combine all that, you're going to have a simplified expression, 2x minus 3y plus 10. Okay, next we have equivalent expressions. Equivalent expressions is two expressions that are equal but written differently. These two lines here are equivalent expressions. This one was kind of expanded out. This one was grouped together. Just like 2x is equivalent to x times an x. There's two sets of x's. A 3x would have 3 x's listed. Okay, so an example of an equivalent expression, I could have this distributive property. One that's not simplified and one that is. These two are equal. They're equivalent expressions. Alright, we're going to simplify the expressions. Then we're going to write letters in the justified column that match our vocabulary words that we might be using on that step. So if we distributed property something, we would write the letter E for distributive property based on the chart above. Or if I used associative property of addition, I would write the letter A. So I'm going to look at this problem and they want me to simplify it. The first thing I see that needs to be done would be the distributive property. It's kind of like order of operations. What needs to be done first? Distributive property. So I would first need to multiply that -3 to both terms. When I do that, I get -12x minus 9, and I brought down my plus 5x because he does not get multiplied. He's the extra tag-along. So what did I do just now to get this new line? I used the distributive property, which is letter E above, so I'm going to write E. Okay. I now look at my problem and ask if it's simplified. I don't have any more distributive properties, so I see if I have like terms, and I see I do have two like terms that I can combine. So I am going to combine those like terms to get a -7x minus 9. And when you combine like terms, above in the chart it says combining like terms is F. So I'm going to label that step F. Alright. You're going to try this one by yourself in a minute when I'm done with my notes. I'm going to go ahead and give you your steps. I want you to do the math work that follows the steps. So the first thing you should do is step E, which would be distribute. Then you would have step C, which would be commutative property of addition. So I would want you to change the order. And then step F of combining like terms. Actually, go ahead and pause the video, try this problem, and I'll show you the answer when you restart. Okay, the solution for when you distribute, I need to distribute this guy here, and I'm just going to get rid of this parentheses altogether. So I distributed, got that there, brought everybody else down. Now step C tells me commutative property of addition. I have straight addition. Yes, that's a subtraction, but that's acting like a -4. It's acting like plus a -4. So I'm just going to change the order of everybody by moving them next to their matching partners. So I'm going to move the x's by each other, the y's stand alone, and the constants by each other. So I shuffle everybody around. Notice how the negative sign went with the 4. The -12 went with the -12. Positives went with those guys. The signs in front travel with it. Now I'm able to do step F, which was combine like terms. So these two terms would be combined because they're alike, and these two terms. And when I do that, I get the following answer. Alright, we're going to now flip on to the back. And it says, by substituting a value for each variable, you can check that your expressions are equivalent. All letters mean in equations stand for some number that we just don't know what it is. So if we make up a number and plug it in and see if our answer is the same answer I would get with my original problem, then I've done something right. I've simplified it right. So first they want me to simplify this just like normal. So I see that I have a distributive property. I need to distribute a -1, and there's no -1s or any other number to distribute here, so I'm just gonna move those parentheses out of my way. So I'll distribute the negative, then move everybody else down. And the property I did just then was distributive, and that would be letter C. Okay, next step I would probably do is shuffle people around and move them by each other. Yeah. So I'm going to move my x's by each other, move my y's by each other, and move my constants by each other. Signs in front of them have to move with them. So I shuffled my people around. Alright, that was step B. And then I'm going to combine my like terms, my x's together and my constants, and I get this, and combining like terms is D. Actually, I don't think those letters are right. I think they got those letters wrong, but we know what we did. Make sure the letters match the first side of that page there. Okay. So we did the first statement of the directions, simplify. Then justify the mathematical, okay, that's where we're matching these. Prove your answers correct by evaluating the expression if x is 2 and y is 1. So to know if I'm correct, in my original problem, anywhere I see an x, I can plug in a 2 and a y 1, solve it. And if I do the same for my answer, my simplified answer, and I get the same answer from the problem and my simplified answer, then I've done something right. So I'm going to go through and plug in a 2 for x. That does not make this a 32, it makes it a 3 times 2. It does not make this a 42, it makes it a 4 times 2. So I'm going to plug in all my work. So I have my 3 times 2 plus 2, plugged in all of that, simplified, and got -8. So for this problem, if x was 2 and y was 1, I got a -8 as an answer. If I plug in those same numbers to my simplified answer, I should get -8 as well. If I don't, I did not simplify it correctly. They wouldn't be equivalent expressions. So, plugged it in. 2 plus 2 times 1 minus 12. Simplify that. I also get -8. So that proves that the original matches my simplified expression. You can always check that. Make up any number you want for your variables. Use the same number when you plug in on your answer on your simplified version, and if you get the same answer, you did something right. So you should be able to get 100% on every test by just simply checking your work. Alright, 1 through 5 at the bottom, you're going to do by yourself and then have me sign off on it. Pay attention here. It says the sum of these two. You need to figure out what the word sum means. You should know what sum means by a 7th grader. So you're going to do 1 through 5, then have me sign off on it.